And welcome to this little run of I'll try to show how to get the points in a paper 2 in marine science. And I just gotten this pen here for a scratch pad, so I'm trying to draw a little more for you. And I must admit the drawing skills I use here are terrible. I'm trying to get better, so I really do apologize for my terrible use of drawing here as I try to draw fish and stuff like that. Please bear with me, you hopefully still get what I'm trying to tell you. So this is a question that comes up a lot in these Cambridge papers, especially in the marine science and biology, where we have to make a large, accurate drawing of the lanternfish. Now, again, I just started working with this new pen for my the drawing here, so I do apologize that this drawing is probably not going to be that good. So the first thing you have to do with the way you're drawing here is you have to make sure that the line, in this case here, is in one piece and is not interrupted. I know this was nowhere perfect. So this is the first point. Then I have to make the fins the same number and approximate the same shape. That's my second point. Then I draw the eye, and then I draw the mouth. What's important to know here is what Cambridge do not want. They do not want any shading. They don't want us to make gills. They don't want us to make any fancy stuff here. If anything, I should do better on a drawing here like this. It is like shape of the tail here should be more like the shape here to make sure I get all the point. And again, this is just a sketch, and you probably do a lot better on your actual paper than I can do here on my scratch pad. But the important thing is here, do not try to make it fancy. Do not try to show gills. No shading, just the outline, the shape, the fins, and the structure, and then you'll get all 4 points. The next question here is about calculation of magnification, also something Cambridge really likes to do. And again, first of all, I have to measure the length here. And if I measure the length of my sample size here, it is 15 centimeters. And I know it is 7 here, the actual length. So 15 divided by 7 is 2.1, but we have to go to the nearest whole number. So my magnification here is 2. As the units, they scratch each other out. So we go back to another version of the extremely badly done fish drawing. You can do better. When we ask to label the caudal fin, see that here, and our lateral line, which I actually forgot on the earlier picture. You need to draw the lateral line as well. So we're asked why the lanternfish has bioluminescent organs, and we should suggest why the lanternfish has these bioluminescent photopores. Well, they have them on the bottom of themselves to reduce silhouette from below, to avoid predation. They also have light to attract mates for breeding. If you want, you can go into more detail here on how having the lighter bottom and the darker top side is something you see in a lot of fish, and how, like, if you see a fish from above, you need to be darker, and if you see it from below, you need to be lighter. This is the concept we're trying to show here. Then we asked why the lanternfish undergoes a daily migration from the midnight zone to the sunlight zone. It's like in the sunlight zone, there's plenty of food, but also active predator. So by going at night, predation risk is reduced. So this is the migration we see from a lot of animals from the midnight and the twilight zone, that during night they go up to feed on the algae and the zooplankton, and then before the daylight comes back, they migrate back down into the darker zones to avoid predation. So basically, you go to the buffet at night and you hide at day. This is the kind of argument we're trying to come with here. The lanternfish is a consumer of zooplankton, but they are also the prey of many fish species that live in the midnight zone. And lanternfish are one of the most abundant species in the ocean. Explain why lanternfish are important in the ocean food webs. Is an explain one. So, well, this is the answer I would give here. So, in the twilight and the midnight zone, there are no photosynthesis and no primary production of biomass. That's one point. So the large biomass of the lanternfish transfer biomass from the surface into the levels below. That's the second point. Thereby being the source of food webs for consumers, predators of higher trophic level in the twilight and midnight zone. I believe this is a way to get all 3 points. So the next one here goes into detail with an underwater plate boundary. So we're in now the chapter of tony plates. And we can see this one goes this way and this one goes that way. So when we have two plates pushing against each other, they are, and this is just something you have to remember, they are convergent. Were they going the other way, they would be divergent, and when they go side to side, they'll be transformed. That's just 1 point for remembering the right name. Easy. So the next question is describe how plate movement at the boundary shown in figure 2.1 can cause a tsunami. It's important to think they're asking how it can cause a tsunami. I had quite a few students describing what a tsunami is and what the effects are. That's not what they're asking. So see if we get this decent. Okay. Not so good, but anyway. In a convergent boundary, the plates are pushing together. The movement of the plates causes tension in the plates. Okay, that's 1 point. A sudden movement of the plates underwater can displace a large amount of water, and the energy from the plates is released and cause a sudden movement of water that can ultimately cause tsunami. It's not the most elegant way to write it, but this is the way to get all 3 points. So our next question is quite long, and we start off actually with a wall of text for 1 page without any questions. But let's start. They show us here we have a tide house, and it's located up here. And you see here you have the recording equipment, you have a wire, you have a float, and here you have seawater, you have your float here. And scientists use 2 methods for the tide house to measure the tide amplitude on the sea and the rocky shore. Method 1 is the scientists use a fixed ruler to measure the height of the water every hour for 24 hours. The second one is the scientists place a float, that's the one we see here, in a tube that's placed in the sea. The float is attached to recording equipment by the wire. The float moves up and down with the water height, and the recording equipment here records the height every 6 minutes. The scientists examine the recording for 24 hours. So these are the facts we have to know before we even look at the question. So we then have our figure 2.3 here, showing us our high tide here and our low tide here, and so on, high tide. But that's not the question. The question is state why the method in method 2 might give a more accurate measure of tidal amplitude compared to method 1. So I'll say that in number 2, there is more measurement and it's more accurate measurements than the ruler. So the fact we're going for is we measure more often and we measure in a way that have fewer potential errors. So we are now asked to suggest one advantage of using method 1, and I would say method 1 is cheaper, as we only need a guide with a ruler, and also method 1 can easier spot anomalies. So if, for example, the wind is building up extra water, that'll be easy to see for a guy observing it, while if you just have machine recording the height, it will just show the height. So the scientists, they state that it's more reliable to use both methods rather than relying on one. State why using both methods 1 and 2 to measure tidal amplitude give more reliable data. Well, you have two sources, so you can spot anomalies. You have a backup. If one fails. And the low tide you can see at 9 a.m. and at 9 p.m. Here comes one of the more classic math questions. At least they're nice here and they give you the formula. And they give us the formula here for the tidal amplitude. And we have to calculate the amplitude recorded here to 1 decimal. So first of all, we've got to measure the highest one. Here, high tide, that is 3.8. And low tide is 0.4. And we divide that by 2. And that gives a tidal amplitude of 1.7. The last question here asks us to explain why the results would be different for a spring tide. And my explanation here would be, well, I'll expect a bigger tidal range at spring tide as the gravitational pull of the sun and the moon is in line and therefore stronger. This will affect the amplitude of the tide, so the high tide will be higher and the low tide will be lower. At the neap tide, the gravitational pull of the moon and the sun is at a right angle, so the pull is less, so the amplitude of the tide is smaller.